In this lesson, we want to review solving compound linear inequalities with and, or. So in our last lesson, we talked about how to solve a three-part inequality. And essentially, we looked at problems like, let's say -4 is less than, you have something like 3x plus 5, which is less than 20, okay? Now, we can leave it like this, or we learned that we could split this up using the special keyword and, okay? So we could also write the same problem as -4 is less than 3x plus 5. And then we would say and you would have 3x plus 5 is less than 20. Now, you wouldn't go through the trouble of splitting this up because this is kind of more complex or more tedious, not more complex, more tedious to solve it in this manner. To solve a three-part inequality, all you need to do is do the same thing to each part. Your goal is to isolate x in the middle, okay? Notice how you just have a variable expression, the 3x plus 5 in the middle. You don't have a variable on the left and you don't have a variable on the right, okay? So all I need to do is just subtract 5 away from each part. Let me kind of slide this down for a moment. And let me slide this up. So -4 minus 5 is going to be -9. So this is less than 3x. And this is less than 20 minus 5 is 15. Okay. So now to isolate x, I just need to divide each part by 3. Very, very simple. And what I'm going to have is, let me kind of erase this. We don't need it. 3 divided by 3 is 1. So you just have x in the middle. This is greater than, -9 divided by 3 is -3. And it's going to be less than 15 divided by 3 is 5. So essentially what we're saying here is that x is a number that is between -3 and 5 with -3 and 5 not included, okay? So it's very easy to look at it in this format here and understand the context of what we're talking about. If I looked at a number line, again, if x is greater than -3 and less than 5, well, I know that graphically, I could just put a parenthesis at -3 and a parenthesis at 5, and I could shade everything in between, right? Those numbers that I shaded there represent solutions for x. If I take any number that's shaded and I plug it in there, I'm going to get a true statement, right? So if I plug in a 2, we could say that 2 is greater than -3 and it's also less than 5, right? Both have to be true. That's the key when you're working with something with and, okay? Both have to be true. If I plugged in something outside of what I shaded, let's say I just took 6. Both are not going to be true here. 6 is greater than -3. That part's true. But 6 is not less than 5. 6 is a larger number. So that part's false, so the whole thing's false, okay? So when you work with an inequality and you have and involved, you've got to think about satisfying both requirements. You can think about it as looking at a job listing that says, okay, you've got to be 21 and have a valid driver's license. Okay, you've got to have both, otherwise no job for you, right? If you're 18 and have a valid driver's license, that sucks, you don't qualify. If you're 22 but you don't have a valid driver's license, that sucks, you don't qualify. I want to jump into some more complex problems with and. These are problems that we typically cannot write as a three-part inequality. So you see that you have more variables involved. With a three-part inequality, you can break that up and use and, but you just have one variable expression in the middle. You have a number on the left side and a number on the right side. With these guys, you have 7 minus 17x is less than -13x minus 5. And then you have and, you have -11x minus 14 is less than or equal to -12x minus 5. So you can't write that as a three-part inequality. So you're going to have to go through the method of solving each one individually and then looking at the intersection of the solution sets. In other words, the areas that satisfy both inequalities. Okay, that's what you're looking for. All right, so let's start with the first one. We have 7 minus 17x is less than -13x minus 5. All right, let's get some room going. We'll come back up. So all I want to do is just subtract 7 away from each side of the inequality. And so I know that this is going to cancel. And -5 minus 7 is -12. I want to add 13x to both sides of the inequality. That's going to cancel. And let me put my less than symbol there. -17x plus 13x is going to give me -4x. So to solve this, I just want to divide each side by -4. And remember, if I work with an inequality, what do I have to do if I divide by a negative? I've got to flip the direction of the inequality symbol. So this cancels with this. I've got x is now greater than, okay, my less than became a greater than, negative 12 over negative 4 is 3. So let's erase this and go back up. So the solution for this part is that x is greater than 3. Okay, now let's solve this part. What I want to do is I want to add 14 to each side of my inequality. That will cancel. I want to add 12x to each side of my inequality. That will cancel. Negative 11x plus 12x is x. So x is less than or equal to. Negative 5 plus 14 is going to give me 9. So we have this x is less than or equal to 9. So let's think about this using my keyword and. Essentially what I have is that x is greater than 3 and x is less than or equal to 9. So again, it goes back to my job listing scenario. You've got to be 21 and you've got to have a driver's license. Well, here x has to be greater than 3 and it's also got to be less than or equal to 9. Let's copy this real quick, and I want to show you this on a number line real quick. So I've got two of these guys, and I'm just going to basically do one on the top and one on the bottom, and we'll see the intersection or the overlap between the two graphs. So if x is greater than 3, I'd put a parenthesis at 3, just shade everything to the right. Then for x is less than or equal to 9, I'm going to put a bracket at 9, and I'm going to shade everything to the left. All right, so essentially what I'm doing is I'm looking for the overlap. So you see this guy right here, if we kind of just put a little dash going down here, 3 is not going to be included, right? So essentially I'm just going to copy this marking and put that here. And everything to the left of 3 is not included because in this solution, it's only things that are larger than 3. So it's got to work for both, and since nothing to the left of 3 and including 3 doesn't work in this one, it can't work in this one. So let me erase this shading. Here, it's anything that's less than 9, so it can go all the way down to the point of 3, but it can't be 3 itself. So let's just shade from here to here, okay? So this is the overlap of the two solutions, okay? So that's what we're looking at. And essentially, I can write this with x in the middle. I can say that x is going to be larger or greater than 3 and less than or equal to 9. And it's also very convenient to write this in interval notation. I can go ahead and say I have a 3, and I have a parenthesis next to that because it's not included. And then comma, I'm going to have my 9, and then a bracket next to 9 because 9 is included. But again, it's got to satisfy both. So again, if I took a number like 6 and I plugged it in there, 6 is greater than 3, and it's also less than or equal to 9. So that's good. If I took something outside of that, if I took 0, 0 is not greater than 3. That doesn't work. 0 is less than or equal to 9, but it doesn't satisfy the first one. And if it doesn't satisfy both, it doesn't work. Again, just think about the example with the have to be 21 and have to have a valid driver's license. You got to have both or you're not getting a job. Okay, so that's the idea. All right, let's take a look at another one with and. So we have 11x minus 2 is less than 18 minus 9x. And we have 16x plus 7 is greater than 1 plus 15x. All right. So all I want to do is just solve these individually, and then again, just put the solutions together. So I have 11x minus 2 is less than 18 minus 9x. You scroll down and get a little bit of room going, and we'll come back up. So I'm going to add 2 to each side of the inequality. So that's going to cancel. 18 plus 2 is 20. I'm going to add 9x to each side of the inequality, and this is going to cancel. So I'll have the less than symbol there. 11x plus 9x is 20x. To get x by itself, very easy. I just divide both sides of the inequality by 20, and I get that x is less than 1. Okay, 20 over 20 is obviously 1. So let's erase everything. So we'll say here that x is less than 1. All right, let's solve this guy now. So if I have 16x plus 7 is greater than 1 plus 15x, again, I'm just going to go ahead and subtract 7 away from each side of the inequality. That cancels. I'm going to subtract 15x away from each side of the inequality. And this is going to cancel. So on the left, 16x minus 15x is going to be x. This is going to be greater than 1 minus 7 is negative 6. So we have x is greater than negative 6. And again, we have this keyword and. So we're looking for the intersection of those two solution sets. So x needs to be less than 1 and x needs to be greater than -6. So you can think about this again by putting x in the middle and saying it's greater than -6 and less than 1. Okay, so it's between -6 and 1, not including either. So let's take this to the number line. All right, so in interval notation, essentially all I would need to do is put a parenthesis, a -6, a 1, and a parenthesis, right? Because -6 and 1 are not included, so you've got a parenthesis next to each one. I'm just basically going to match this format on my number line. X is between -6 and 1, and -6 and 1 are not included. So a parenthesis at -6, a parenthesis at 1. I'm just going to shade everything in between. All right, let's take a look at one more of these with and then we're going to move on to the keyword or. So we have 5x plus 15 is less than or equal to 8x minus 12. And then we have 15x minus 3 is less than 14x minus 4. So we'll start out with the guy on the top. We have 5x plus 15 is less than or equal to, we have 8x minus 12. So I'm going to subtract 15 away from each side here. So that's going to cancel. You're going to have 5x is less than or equal to, you'll have 8x, and then -12 minus 15 is -27. I'm going to subtract 8x away from each side of the inequality. So that'll cancel. And I'll have 5x minus 8x, which is -3x. And basically this is less than or equal to -27. So if I divide each side here by -3, again, what do I got to do? I've got to flip the direction of the inequality symbol. So this becomes a greater than or equal to. So I would have x is greater than or equal to, -27 divided by -3 is +9. So we've got x is greater than or equal to 9. So we have x is greater than or equal to 9. Okay, for this guy right here, I would add 3 to each side of the inequality, and then I would subtract 14x from each side of the inequality. So that's going to cancel, and that's going to cancel. 15x minus 14x is x, and this is less than. -4 plus 3 is -1. So let's erase this. We're going to say that x is less than -1 here. So again, when we put our kind of and statement in between these two, we get that x is greater than or equal to 9 and x is less than -1. Okay, x is less than -1. Now, before we kind of think about this, let's look at a number line real quick and see where we get a problem here. So let's paste this guy right here. Let's first graph x is greater than or equal to 9. So at 9, I would put a bracket and I would shade everything to the right. Let's graph x is less than -1. So at -1, I would put a parenthesis facing to the left, and I would shade everything to the left here. Okay, all of this area. Now, do you see an overlap between the two solution sets? No, you don't. You can't have a number that is less than -1 and greater than or equal to 9. It's not possible. Okay, so when this happens and you're using the keyword and, you don't have a solution. So for the compound inequality, you just say no solution, right? Individually, for each inequality, there's a solution. But for the compound inequality, again, for the overlap of the two solution sets, it's not possible. So you just put no solution. A lot of teachers will like you to put the symbol for the null or empty set. It's that right there. So you can put that as well. But you're basically just saying that there's no solution. All right, so now let's think about the keyword or when we're talking about compound inequality. So let's go back to our example with the job. With and, we said we had to be 21 and have a valid driver's license. Okay, you had to have both. But let's say we replaced it and said you had to be 21 or have a valid driver's license. What does that mean? It means if I have a valid driver's license, it doesn't matter how old I am. I can apply for the job and I can get it. It also means if I don't have a driver's license and I'm 21, I can apply for the job and I can get it. If I don't have either, right, if I'm not 21 and I don't have a driver's license, well then I don't get a job, right? But if I have at least one of them, then I'm okay. If I have both, I'm okay. So that's the situation with or, right? It can be either of them or it can be both of them, okay? So if we look at 9x plus 20 is less than 16 plus 11x, or -x plus 13 is greater than 5x plus 19. Okay, so we're going to solve each one individually again. So let's write this one down here. We have 9x plus 20 is less than 16 plus 11x. Let me get a little room going. Come back up. So what we want to do is subtract 20 away from each side. And let's just go ahead and subtract 11x away from each side. And we can cancel this, and we can cancel this. And what do we have here? 9x minus 11x is negative 2x. This is less than 16 minus 20 is negative 4. So to get x by itself, I just divide both sides by negative 2. And I've got to flip the direction of the inequality symbol because I divided by a negative. Right now it's a less than. It's going to become a greater than. We would have x is greater than. Negative 4 over negative 2 is 2. So we've got x is greater than 2. So let's erase all this. So x is greater than 2. Okay. For this one right here, we can subtract 5x away from each side. And we can subtract 13 away from each side. So this cancels and this cancels. You would have negative x minus 5x, that's negative 6x. This is greater than. 19 minus 13 is going to be 6. We would divide each side by negative 6. And again, I'm dividing by a negative, so I've got to flip the direction of the inequality symbol. It's a greater than right now, so it's going to become a less than. So x is less than. 6 over negative 6 is negative 1. So we would have or x is less than negative 1. So let's erase this. And again, all I'm going to do here, I'm just going to drag this down to the number line. So if x is greater than 2, I could put a parenthesis at 2, and I could just shade everything to the right. For x to be less than negative 1, I could put a parenthesis at negative 1, and I could shade everything to the left. Okay. Think about the fact that if you had and here, you would not have a solution. There's no overlap. But we don't have and. We have or. Remember, if I'm going for my job and there's an or, I can be 21 or have a valid driver's license. I can get it either way. So here, x can be greater than 2, or it could also be less than negative 1. Either of these works, okay? Either of these works. The only numbers that don't work are from negative 1 to 2 with negative 1 and 2 included, okay? So in interval notation, to kind of show this concept, we need to use a union symbol. Some of you have seen this. You've talked about sets before. We'll talk about sets more in depth later on in the course. But for right now, you have this U looking symbol, and it stands for the union, okay? It's not an actual U, but it looks like a U. So this is the union. So I'm going to place this between the two intervals to combine them as a union, okay? So what I'm going to do is I'm going to say that x can be from negative infinity up to and not including negative 1. So that's kind of the first solution here. That's this one right here. That's the one coming from the left, coming from negative infinity up to but not including negative 1. So I'm always going to put that on the left because it's on the left in the number line, right? And then I want to use my union symbol. So I want to use my union symbol. Again, looks like a U. It's not a U, but it looks like one. And then I'm going to look at the solution on the right in terms of the number line. So it's going to start with any number greater than 2. So I'm going to put a 2 next to a parenthesis, and then comma, it goes out to positive infinity, okay? So it's again, the union of the two solution sets. You've got this guy right here, again, coming from negative infinity up to but not including negative 1. It's the union with this guy right here, anything larger than 2, again, going out to positive infinity. All right, let's take a look at one more of these. Very, very easy concept overall. So we have 15 plus 13x is greater than or equal to, you have 5 plus 18x, then or, you have 1 plus 5x is greater than 4x minus 6. Again, I'm just going to write this one down here. So 15 plus 13x is greater than or equal to, you have 5 plus 18x. So what I want to do, I want to subtract 15 away from each side. So that's going to cancel. And I want to go ahead and subtract 18x away from each side. Let me make that 8 a little bit better. So that's going to cancel. All right, let me get a little room going here. So 13x minus 18x is going to be negative 5x. This is greater than or equal to 5 minus 15, or 5 plus negative 15 is negative 10. And so I'm going to divide each side by negative 5 so that I can isolate my variable x. Negative 5 over negative 5 is obviously 1. You would have x is, remember we divided by a negative, so this gets flipped. X is less than or equal to 2, right? Negative 10 over negative 5 is positive 2. So x is less than or equal to 2. So again, x is less than or equal to 2. Okay, for this guy right here, I'm going to subtract 1 away from each side. That cancels. I'm going to subtract 4x away from each side. That cancels. 5x minus 4x is x. This is greater than. Negative 6 minus 1 is negative 7. So you just get that x is greater than negative 7. All right, so let's think about this again using our number line. A lot of times it's very easy to visualize the solution. So we have x is less than or equal to 2, or we have x is greater than negative 7. So let's go ahead and copy this. All right, so let's think about x is greater than negative 7. So greater than negative 7, I'm just going to put a parenthesis at negative 7, and I'm going to shade everything going to the right, including my arrow. And for x is less than or equal to 2, I would go to 2 and I would put a bracket there. And I would go ahead and shade everything going to the left. Let me use a different color here. So I would shade everything going to the left. So what you'll see here is that your solution set would be all real numbers. So any real number would work in at least one of them. So the ones that would work in both fall in the category of between negative 7 and 2, with negative 7 not being included because it's a strict inequality, and 2 being included because it's a non-strict inequality. So any number in that range would satisfy both, okay? But outside of that range, we would fall in the category of one of them. So it would work in one and not work in the other. But again, because we have the or, it only has to work in one of them. So I can take any real number that I would like, and I would get a correct answer if I plugged it into the compound inequality, again, because of the or. Okay, so I can just say that my solution here is all real numbers. Okay. Now, one way you can notate this, we can just erase kind of these markings here. You can just shade the entire number line graphically. So I can just shade this whole thing and just say that they all work. Okay, everything from negative infinity to positive infinity. In interval notation, that's exactly what you would put. You would put from negative infinity to positive infinity. So all real numbers.